Hello, everyone. In this video, we are speaking with Kathleen Salazar-Serna about her model, Urban Transport Mode Choices. Kathleen, thank you for taking the time to speak with me.
Thanks for inviting me.
So let's start with your model. Can you tell me a little bit about your agent-based model?
Sure. The model is essentially a simulation tool designed to help evaluate urban transport policies, specifically to understand what might happen when a city decides to implement a measure to reduce traffic congestion or emissions or road accidents, which are basically the externalities associated with motorized travel in urban contexts. And the core idea behind the motivation of this work is that transport mode choices is not a rational calculation, and commuters do not make travel decisions in isolation. Their choices are shaped by a combination of several factors, such as individual preferences, sociodemographic conditions, spatial characteristics of the city, and the influence of their social environment. In traditional statistical approaches that have been the standard in this field, they often fall short in capturing these dynamic and social dimensions of decision making. And maybe if I show you the conceptual model, I can explain better how it works. Here on the screen, so we have that in the model, we are representing urban commuters that are traveling at the peak hour, and we have men and women of different ages or socioeconomic backgrounds who choose among three transport modes. So we have public transit, private cars, and motorcycles. This model was meant to analyze transport dynamics in developing countries, and motorcycles are the predominant vehicles in those places. So that's why they are included in the model. So people start the simulation using one of these transport modes. They make a trip and accumulate experience, user experience, and also calculate or evaluate satisfaction with this trip. And they consider different transport attributes like travel time, cost, comfort, road safety, personal security, and environmental impact. And with this information, they evaluate a mental model, which is grounded in the consumer framework, which integrates different behavioral theories to explain how individuals select products or services under different levels of satisfaction and uncertainty. And these agents evaluate that mode choice and follow one of the different decision strategies to select either the same transport mode or change it, so they can repeat, deliberate, imitate, or inquire, and then start the cycle again. And through policy interventions, we can change the status of the system, which in turn change the decision-making process. And this is the main way that we are representing those urban commuters. And here we have the interface of the model. So we are representing people that are located in one neighborhood in the city, and these colors correspond to the socioeconomic background. And we are representing here one area in the city where we have many services and businesses. So people are mainly going to that area, which is representing the most congested region in the city. And while we are calculating this satisfaction with the trip, also there are many things going on in the model. We are having road accidents, we are having security incidents, And also we are tracking some indicators such as travel time, distance, waiting time. And based on that, people calculate satisfaction and they select one of the transport modes. So this is basically the way that the model works.
Very interesting. Is the map an abstract map, or is that a specific location?
That version of the model is an abstract representation of the city, but now I have a newer version that I will show you later, where we have a closest representation of the city using geospatial data.
Okay. So I noticed a large amount of net logo parameter bars at the end. I was going to ask what sort of the challenges were with your model. Is that one of the challenges, is just understanding the parameter space?
Yeah, great question. I will say there were two major challenges throughout this process. The first one is more conceptual, and the second one is more related to implementation. And in that implementation, these parameters are related to, and I will explain later why. Let me show you my screen again to show you what's what the components of the model are. So I already mentioned that we were using the consumer approach to represent human behavior. And here appears the first challenge, is that we needed to represent explicitly the social influence in the decision-making process, especially for those groups of decision makers that needed to go into social engagement to gather information or share data with others. And the solution was to build a social network that connects agents and allows them to exchange information to deal better with uncertainty. And this is particularly important because if they don't have enough personal experience with a transport mode, they can look at what their contacts are doing and use that as a reference. And for the network structure, I tested different topologies. And finally, in this version of the model, I implemented two complementary networks: a scale-free network that reflects homophily, which is the tendency of people to connect with those that have similar characteristics to them. And also I'm using a small world network that introduces connections across different socioeconomic classes. And in the model, the people in the same group could be neighbors, and those in different socioeconomic classes could be co-workers or friends living in different parts of the city. And together, these two structures capture how real social networks actually work in urban settings. And the other major challenge was the data collection. We have information from the city, like records of road accidents, statistics or demographics, and information about the distribution of the transport modes. But what we didn't have was the perceptions that people have regarding transport attributes like comfort, cost, time, security, and what level of importance these people place on those attributes. And that was very important to weight the satisfaction calculation. What's the level of importance for each of these attributes that they are evaluating? So in that case, I had to design and implement a survey, and that was another challenge because, that it requires time and it costs money. So yeah, that was the other thing. And those are the sliders that you can see here. Depending on the socioeconomic class, people have different levels of importance based on those attributes. So I use this to represent that, and values to parameterize that are coming from the survey.
Interesting. So it seems like you've already done a lot of work with this. What sort of insights have been coming out of the model?
Well, the model analysis focus on testing different policy interventions to see whether they could effectively reduce those externalities that I mentioned before, like road accidents or CO2 emissions or traffic congestion. And perhaps the most important finding is that urban transport systems have a lot of inertia. Like, it's not easy to shift how people move around the city because commuters tend to stick with what they know. And the other point is that single measure interventions rarely produce meaningful changes. A good example of this is fare reduction in public transit, for example. So intuitively, you will expect that making public transport cheaper or even free, which we tried in our model, will attract more users to prevent to the public transit and prevent people from migrating to motorcycles or cars. But results showed that even when this price is set to zero, the increase in public transit ridership, it was only about 4% compared to the baseline scenario. And that shows that cost alone is not the deciding factor for most commuters.
Yeah.
And what actually showed some changes was targeting safety perception and frequency. And that had stronger effects on modal choices. And the other thing is that we found that combining these interventions simultaneously, we could have reductions in those externalities. If we implement the fare reduction, increased frequency, and increase the perceived security perception, we could have about 5% of reduction in CO2 emissions per year and 14% of reduction in road accidents, which is a very critical thing, especially in countries in Latin America where we have very high accident rates. So in short, the model not only help us to identify which interventions are most effective, but also demonstrated that coordinated and multi-factor policies are essential for generating real change in cities, especially in those with high motorcycle dependency.
Okay. So you mentioned, I think you already mentioned sort of a newer version of this model. Is that sort of what's next? Is increasing the detail?
Yes, this is the most exciting thing about this project because the model is actively evolving. And if I share my screen again, I can show you a new version of it. So now we have a more accurate representation of the city. Here we have the urban area of Cali, which is a Colombian city that we use as a case study. And here we have the different communes, which are groups of neighborhoods. And if you see here, people are moving, and now they're not just going to one of the most congested areas in the city, but here we have a more accurate representation of trajectories because we are using origin destination service. So people are going to different places based on that patterns. And we can see how congestion occurs in those areas where we see the red color. And that helps to observe in a better way how people move around the city. So that's one thing that we are updating the model. And on the other hand, we are applying this model to different Colombian cities. For example, one case that we are analyzing right now is the willingness to adopt a new mass transit system in an area where they are thinking of investing in a BRT or metro infrastructure.
Okay.
And the other case that we are working on is together with the Inter-American Development Bank, we are analyzing traffic decongestion policies for Trinidad and Tobago. So yeah, so those are the next steps.
Very interesting. Do you foresee, I guess in some of my past research, I've used cell phone data as they have sort of an anonymized cell phone data of where people are moving. Do you think you might be able to someday get something like that to compare, to really have fine-grained detail of where people are moving and going? And
Yes, that will be awesome to have.
yeah.
Unfortunately, here is a little bit expensive to have access to those data sets, but that will be a very good way to have more information about these
Yeah.
patterns of mobilities and these areas of the city where you have more traffic congestion, or relate that to the services that you have in the city, and try to think of some policies for urban planners to see how to plan or think of these services, how they should be located in the city to avoid long distances for travel. And yeah, that will be a very, very good way to
Yeah. Well, your model just seems really, really detailed and seems very, very well put together and predictive. And so that's why I'm trying to, it seems like the next natural step is even more exact data. So
Yes, yeah, that's a good idea. I
yeah,
will think about it.
in an
Thank
ideal
you.
world.
Yes.
Yeah.
But who knows, maybe one day with some funding, we can get it.
Well, thank you, Kathleen. I appreciate you taking the time to talk with me today about your model. If anyone would like to try out Kathleen's model, it's available on COMSIS, and the link is included in the description below.
Thank you.